we're diving into the fascinating world of sensory deception. Can our eyes deceive us? Can our ears play tricks on us? Get ready to explore the mind-bending world of illusions and how easily our brains can be fooled. Let's start with something you've probably encountered before: optical illusions. Take the Müller-Lyer illusion, for example. You see two lines, one with arrows pointing inwards, the other with arrows pointing outwards. Which line looks longer? Most people would say the one with outward-pointing arrows appears longer, even though both lines are the same length. Our brains use context and past experiences to interpret visual information. In this case, the inward-pointing arrows trick our brains into perceiving that line as closer and shorter. Now, imagine this: feeling a limb that's no longer there. It's a strange reality for many amputees who experience phantom limb sensation. They might feel pain, itching, or even temperature changes in a limb that's been amputated. Even though the limb is gone, the nerves that used to carry signals from that limb to the brain are still there, firing spontaneously. The brain tries to make sense of these signals, sometimes concluding that the limb is still there. Our ears can be fooled just as easily as our eyes. Have you ever heard of the Shepard Tone Illusion? It's a sound that continuously rises in pitch, forever ascending. This illusion plays a series of overlapping tones, each with a slightly different frequency. As one tone fades out, another fades in, creating the illusion of a continuously rising pitch. Our brains, wired to perceive patterns and continuity, fall for this trick: hook, line, and sinker. Our sense of touch, our perception of temperature, can also be tricked. Have you ever noticed how a lukewarm pool can feel refreshingly cool or surprisingly warm depending on the air temperature? That's because our sense of temperature is relative. Fill 3 bowls with water, 1 hot, 1 cold, and 1 lukewarm. Place one hand in the hot water and the other in the cold water for about a minute. Now, plunge both hands into the lukewarm water simultaneously. The hand that was in the hot water will perceive the lukewarm water as cold, while the hand that was in the cold water will perceive it as warm. This discrepancy arises because our temperature receptors are more sensitive to changes in temperature rather than absolute temperature. Even our sense of taste, the gatekeeper of culinary delights, isn't immune to deception. Ever notice how something sweet, like a soda or candy bar, can make other foods taste less flavorful or even bitter? Our taste receptors can become tired or biased after exposure to a particular taste. If you eat something very sweet, your taste buds for sweetness become less sensitive, making it harder to taste the sweetness in other foods. At the same time, your taste buds for bitter flavors may become more sensitive, making those flavors more pronounced. Our brains are constantly working behind the scenes to adjust our perception of the world, and color perception is no exception. Take a look at a white piece of paper indoors under artificial light, and then take it outside under the bright sun. The color of the light reflecting off the paper changes, but our brains compensate for this, making the paper appear consistently white. This phenomenon is known as color constancy, ensuring that the color of an object appears relatively constant under different lighting conditions. Have you ever stared at a waterfall for an extended period and you then looked away, only to find that the stationary objects around you seem to be moving upwards? It's called the motion after effect. It occurs because the neurons in our brains that detect motion in a particular direction become fatigued after prolonged stimulation. When you look away from the moving stimulus, these fatigued neurons fire less strongly, creating the illusion of motion in the opposite direction. Now, let's talk about synesthesia, a fascinating neurological phenomenon where the stimulation of one sense triggers involuntary experiences in another sense. People with synesthesia might see certain letters or numbers as having specific colors, hear sounds when they see movement, or even taste words. Synesthesia arises from unusual connections or cross-wiring in the brain, where sensory pathways that are typically separate become intertwined. So there you have it, a glimpse into the fascinating and often deceptive world of our senses. From optical illusions to synesthesia, our brains are constantly working to make sense of the world around us, even if it means taking shortcuts or filling in the gaps. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into the human mind and senses. See you next time.